If you're into Stable Diffusion and text-to-image models, then you're in for a treat. I picked some of the prompts from Leonardo and compared it to this new method. For this, line pencil drawing female face, that's the new method. Then I asked the prompt to simply increase the size of the crown, and here's output. I used this prompt from Leonardo, and let's compare it to the new method. It looks so much better. Then I picked this image from Leonardo. These are some of the trending images. Here's out from the new model. You might be thinking, what's so special about this new method? With this new method, it adheres to the prompt way more closely than the regular Stable Diffusion. For example, I picked this prompt that says depict Ymir, the giant leader, as a colossal and imposing figure using imaginary to convey the threat he poses to Asgard. And here's the output. So if you look closely, this might look like a regular image, but if you look how it's showing the scale of the giant, like this is the mountain and the giant's foot is equal to the mountain, that show how big this character is. Let me give you another example. So in this photo, the prompter has asked to have a pastel color powder spreading in every direction, and then it's asked to have a jellyfish, like to have the powder in the shape of jellyfish above water, whereas like there is no powder. I don't see any powders, there is only a jellyfish. That's see how the new method did it. I agree that the powder is not in the shape of jellyfish, but that would be extremely difficult for the model to generate. I think it has sand, so I think it's on a beach above sea level or water level. I don't know. The prompt also asks for a wall. I don't see any walls. Then I took this prompt which says suspended above the clouds, dynamic pose, well, premistic solar angel, glowing halo, and she's not suspended in mid-air. There's no halo. And let's look at the new method. Way better. I know the eyes are not correct. The hands are not correct either. But it adheres to the prompt way better. I'll explain why the reason is for the eyes and the hands. Then I use this prompt for this image, and here's the output from the new method. The one from Leonardo looks way better, but it followed the prompt quite well. We also picked this prompt. So it says beautiful daughter of space among the cosmos, fire in her eyes. I don't think I see any of those in this photo. Skin made of star, showing parts of her. So now let's look at the new method. In this one, it did follow, like there is sky in her skin and there is skeleton as well. With that being said, welcome to the channel. So this new method is called Omost. It is available on GitHub that you can download and use. So based on the GitHub page, the almost pronounced as almost and has two meanings. Every time you use almost, your image is almost there. The O means omni and most means we want to get the most out of it. I have it running locally, so we're just going to check how it works and then we're going to go through some prompts. So the first prompt that I'm going to use is a dog and cat, the dog on sofa. So let's submit. So I asked a dog and cat, dog on the sofa, the dog on the sofa, and it has put both cat and dog on the sofa. The reason I chose this prompt is for a specific reason, because with normal Stable Diffusion models, when you say a dog and cat and then say the dog on sofa, sometimes they think there is another dog that needs to be on the sofa, whereas with this one it would not confuse. It's unlikely for it to confuse. It would know when you say the dog that you're referring to this dog. I have the technical detail towards the end of the video, but I just want to go through like what is involved to get this to work. So the way they've done this is by fine-tuning LLM models to generate a specific type of code that adheres to a specific syntax, like using a library. In this case, they provide Llama 3, Phi 3, and Llama 3 Dolphin version. The magic comes from using a large language model, because a large language model understands the text, whereas with normal diffusion models, it does understand your text but is not as clever. So diffusion models know about concepts and how to put them together, but it does not have world knowledge, whereas large language model compress inside them world knowledge. That's where it comes in handy in this method. With that being said, now let's get to prompting and generate some images. I used this photo and used this prompt, and I've got this result with the new method, which is quite similar to the one here, original one. Then I used the same prompt in Leonardo itself using the same model, and here is the result. With this new method, we speak to the LLM, and the LLM talks to the Stable Diffusion. So because of that, we can do things like we could ask it to reduce the size of umbrella. Only if I could type. Here's the result, which is not good. Here's the original from the original prompt, and here is like asking you to reduce the size of umbrella. It actually is almost the same size. And yeah, the new method is not perfect, but it's going to keep getting better. Also, I wanted to mention that some of you might, by looking at these texts, you might think that this is just a prompt optimizer, but the short answer is no. But as I will explain towards the end, it goes way more into how this all works. There is way more to it than just prompt optimizing. Next, I use this prompt: double exposure complex art by Alex Todard, I think. Postcard on a cracked paper, extremely dynamic, unusual vintage, and this is the result, which I think is quite good. And the one from Leonardo is not bad either. So this new method actually uses Stable Diffusion as well, and the Stable Diffusion model that I'm using, which is the default with this Git repository, is the real Wiz XL version 4. So given that now with this new method there is two components to this whole pipeline, there is an LLM and there's also Stable Diffusion. So it means that you would have benefits of both, but also you would have drawbacks from both as well. So what I meant is, like, if your Stable Diffusion model is not good with eyes or with hands, then it would show in the final result. And if your large language model is not intelligent enough, it would not be able to describe the image properly to the Stable Diffusion model. I have used or tried to use Stable Diffusion before. I like it, but usually quickly gave up because the models, they don't follow the prompt closely, as it is very difficult to get the image right. So I have picked this prompt, and this is the image and from Leonardo, and this is from the new method. So the prompt says, imagine a vibrant canvas illuminated by a cascade of colorful binary code forming the silhouette of a captivating woman. The dynamic lines and patterns reminiscent of a digital dance weaved together to create a harmonious fusion of technology and art. The way this prompt is laid out is like a normal English. There is not a lot of prompt engineering going, whereas with other prompts you would see a lot of keywords. You just have to speak in plain English. You don't have to do a lot of things that you normally do with Stable Diffusion. In this case, both Leonardo and the Omost have followed the prompt very closely. Next, I use this prompt, and here's the image from Leonardo. Here's the result from the new method. It adhered to the prompt quite well. Now let's get into the technical details. So with this new method, when we give it a prompt, it would generate, the LLM will take the prompt and write a script for us. In this script, it uses canvas to describe what the image is. So like you can see, like, it sets a global description, add a local description where it should be the offset distance to the viewer, and the description style, color. I believe the color is used to define each object in the scene and where it is. So the virtual canvas that we just talked about is divided into 9 grids, and then each section is further divided into their own 9 sections. And then the new method has defined 9 different bounding boxes. So this way you get to 729 different bounding boxes, which covers almost all locations of an image. So the LLM will take the prompt, then think what it wants to draw, and then it would describe what each section of the image look like. So as I mentioned earlier, that there are some colors defined in this method, and it's being used with the location information that's provided by the LLM and the objects with the color. So it uses different color and object to define where they should be in the scene. So in this example, they've given a green bottle in front of a red bottle on a wood table in a dark room. So it would generate an image something like this, which would be the noise image, and this will be fed into Stable Diffusion. If I'm getting something wrong, please feel free to correct me in the comment section. So once the LLM has decided which object goes where and has instructed to construct something like this is then used to create the initial latent encoding and use denoise strength of like 95 to 99 to generate the image. To guide each region to the diffusion model, they're using something called attention score manipulation. So they've provided a simplified example of how this works. So if you imagine this is a 4-pixel image, then if you say all the regions have 2 cats and 1 and 3 have a black cat and 2 and 4 section have a white cat. So what they would do, that it would increase the attention on the, when it comes to 2 cat for the 1, 2, 3 and 4 pixel. But for black cat, the attention would be high on the first box and third box, but reduced on the second and fourth, and the same for white cat. So to me, it feels like the LLM acts as an interpreter that takes a prompt from you and then adds its own imagination, and then becomes a director of where the images should go, what should come in front, and like what should the atmosphere be like, and then use that to draw something like this, which will be used as a latent encoding to generate the final image. I believe there is a lot of potential for this method. I probably myself would be using it in the future. Just thinking out loud, it might even be possible that in the future version they might include X, Y, and Z. So you can get like a 3D environment out of this and then draw from that. I don't know, just thinking out loud. Also, I just wanted to point out some of the drawbacks of this new method is that it generates a lot of text and that takes a lot of time. But what that gives you, that image that adheres to the prompt more closely. Maybe this is like an alternative to a Stable Diffusion 3 that's coming soon, I guess. Another kind of drawback of this method is that now, given that there are more moving parts like the LLM and the Stable Diffusion, so those moving parts will impact of what the output will be. For example, if your Stable Diffusion model is not good at drawing something, hands or eyes, they would not generate good eyes. So that's one thing. And if your LLM is too censored, which Llama 3 is, so if you mention something that it doesn't like, it would just silently ignore those and you wouldn't know why. But overall, it's a really good thing. You guys would love to play around with it. Go check it out. And I hope you guys like the video. If you feel free to like, share, and subscribe. Thank you.